Big tech has an advantage, right? Tons of money for tons of engineers to build powerful infra. But you can build on top of that same powerful infrastructure with CockroachDB. The founders came from Google, and they've basically built open source Spanner, but with a serverless option that you can use for free. Check them out at cockroachlabs.com/devdiscuss. Scout APM is leading-edge application performance monitoring designed to help developers quickly find and fix performance issues before the customer ever sees them. See why developers call Scout their best friend, and sign up for your free 14-day trial. No credit card needed at scoutapm.com/devdiscuss.
Often, the smaller part of the code is responsible for most of the users. And once we detect such a code, I'm calling it hot path, it's a lot easier to focus optimization efforts.
Welcome to DevDiscuss, the show where we cover the burning topics that impact all of our lives as developers. I'm Ben Halpern, a co-founder of Forum, and today we are talking software mistakes and trade-offs with Tomas Lelek, senior software engineer at DataStax and author of the book, Software Mistakes and Trade-Offs, Making Good Programming Decisions. Thank you for being here.
Thanks for inviting me.
I imagine you are abundantly qualified if you're going to be writing a book about mistakes and trade-offs, such a fundamental part of software development. So is there any part of your career or challenge that particularly led you to wanting to author a book called Software Mistakes and Trade-Offs? Or was it sort of more just an aggregate thing? Like any particular challenge informed this book more than something else?
I think no, it was an aggregated list of those trade-offs, decisions, and also mistakes. So I was collecting a list of those things from the beginning of my engineering career, some kind of a decision log with pros and cons and different paths that we could take as a team. And it was at the really low level, like code level, but also architectural level, which solution to pick, how to build a more complex system. And then I was observing how does it evolve in the future, because I was maintaining those systems. So I have possibility to observe how systems behave on the production. So what was our assumptions and how it turned out in the real life, and also what I would do differently if I would be able to get back in time and maybe pick something else.
How much do you consider these topics to apply in all domains of software development, or is there any kind of application, layer of the stack? Like if I do systems development versus front-end development, do you have a sense that like some of these themes apply more to certain domains? And are there some that sort of stand out as like the most fundamental, no matter what subdomain of this craft you're in?
The book is targeted to backend developers for sure. On the front end, there are different challenges, different patterns. All my professional career, I was working as a backend developer. So this is my expertise. Maybe in the future, someone will write a similar book about front end. But as long as you need to write some backend stuff, even if you're a full stack engineer, I think you will benefit from this book. I mean, you don't need to write all the chapters. For example, there is a chapter about big data processing and data locality. If you are building services, APIs, that doesn't need to deal with storage, right? Maybe you can skip just this chapter. But on the other hand, there is a chapter about distributed systems and calls in them, in distributed systems, how to retry operations, how to design your API to be idempotent, and so on. So even if you are full stack, I think you may benefit from this chapter.
Another question about, what the fit of this book is versus, different folks in different parts of their career. And I am certain this is, broadly relevant to anyone, but I'm curious if you feel like from a specific programming languages and maybe the cultures that surround them, as well as specific, programming environments, like maybe working in a startup versus a bigger organization. is there a sense of, like trade-offs within the trade-offs or anything where you feel like certain lessons can apply better for a C++ developer versus a Ruby developer, and the sort of trade-offs within these paradigms?
Yeah, so I had pleasure to work with both environments, in more startup environments and also in more corporate environments, bigger company. That was not purely technological company, but technology was just a tool to achieve business goals, right? And all the patterns in this book apply in both of those domains for sure. So I would not say that if you are working in some legacy, you will not benefit from that. Even I would say differently. Maybe you will see different patterns for solving the same problem, how to evolve your data, how to build anti-corruption layer, what technologies use, right, to encapsulate old stuff. And regarding experience of developers, I personally would love to learn such a book at the beginning of my career. But on the other hand, I think that if someone has some experience, like 1 or 2 years or so on, such a person will benefit from this book more, right? Because he can relate the examples, the problems, to his personal experience. However, at the Manning publisher, at the review stage, the whole book, all chapters are reviewed by 30 persons, right? 30 engineers. And the experience of them vary a lot. Like there was some junior developers, but also some architects with like 15 years of experience. And I think both of those groups benefited from the book.
So the first chapter of the book is called Code Duplication is Not Always Bad, with the subheading of Code Duplication versus Flexibility. Can you dive into this topic a little bit? And this seems very broadly applicable as well. Any domain of software development is going to, have to think about this type of trade-off. And can you expand on this one a little bit?
Yeah, this is a good example, also referring to the previous question. So, if you are at the university, everyone is teaching you the dry, so do not repeat yourself. And this will be mostly good rule in most of the contexts. And at the beginning, it's a great, right? But as you gain more experience, you are start noticing that maybe you shouldn't follow this rule blindly, right? And this is when this chapter comes in and the topics discussed in this book. So there are two parts in this chapter. One is at the architectural level, and second one is at the low-level code level. So at the architectural level, I'm considering a case when we have multiple services, microservice architecture or multi-services architecture is very popular now, and a lot of architectures involves this separation. And if you have, like, for example, two code bases, there is often a case that there is some common code between both of those. It can be like some very simple logic for validating your stuff, or validating the token for authorization, and so on and so on. And if you would follow this dry, it would mean that every piece of the code needs to be refactored, abstracted away, and shared by those two microservices. It can be shared using library or other microservice, but it comes with a cost, right? So firstly, you need to maintain this separate part of the code, but also it introduces tight coupling between this code and your microservices. And it may turn out that you started to abstracting away your stuff too early. Maybe this common code should evolve in a different ways, right? And if you have this abstraction, you are tight coupled to it, it's harder to evolve. And thus you have worse flexibility, and it may impact the speed of delivery of your software. So this is the trade-off basically. And second part is at the code level. So I'm considering inheritance and also design of components that are using inheritance as a pattern to reduce duplication. And in some cases also it limits the flexibility of components that are extending this parent class. And we'll also consider composition there.
Seems like other chapters in this book kind of help, support the argument you're just making now. So we have a chapter called Balancing Flexibility and Complexity, which is kind of, like a supporting argument for the whole idea of code duplication versus flexibility, I imagine. And there's also like premature optimization versus optimizing a hot path, decisions that impact code performance. So when you're talking about, trade-offs of duplication versus flexibility, sometimes the trade-off is a matter of complexity and tying yourself to an abstraction which may be wrong, and that's probably a matter of complexity. And then there's also the optimization decision. And these kind of both seem to tie into this first idea of duplication versus flexibility. Sometimes it's a matter of complexity as the trade-off, and sometimes it's a matter of performance. Would you say like those topics all tie reasonably effectively together? There's also a chapter called Simplicity of Your API versus Cost of Maintenance. So I'm just sort of plucking a lot of things that I think like are highly relatable thematically, and I imagine why they fit into a single book. Can you speak to kind of the relationship between some of these chapters?
Yeah, so about balancing flexibility and complexity, one of the aspects could be, as you mentioned, duplication, right? But it's described in this second chapter. So in this one, I'm going into a bit different direction. It's from the perspective of someone that is developing code that will be used by other persons, right? So it can be within your company, you are designing a component that will be used by other code paths, other folks in your organization. That's often the case, right? In such a context, it is often tempting to try to over-engineer your component, right? To guess all possible functionalities, all possible use cases up front. And for example, I'm showing one of the patterns for achieving that. So library that allows clients to plug some custom behavior via listener API or hook API, right? And this sounds awesome because you are giving a lot of flexibility to your clients. Well, this is what I think one of the most flexible mechanisms, because clients could do anything they want in those code paths. But on the other hand, you are raising the complexity, and where the complexity is raised. So mainly it is raised because you are not able to anticipate all use cases that customers can use your code. For example, in JVM languages, they could throw runtime exceptions everywhere. You don't have influence over it, and you need to expect anything. And this expect anything means that your code will grow to be more complex and complex. Also, there comes a threading model. If you don't have as clear documentation how it should be used, the customers may block processing and to choose impact in your whole application, right? If you have non-blocking event loop, such a thread could be blocked, and also you increase complexity. Even if you are documenting this well enough, maybe not everyone will read the documentation. So at the end, you still need to handle those cases, even if it's documented.
Scout APM pinpoints and resolves performance abnormalities, like N+1 queries, memory bloat, and more, so you can spend less time debugging and more time building a great product. With a developer-centric UI and tracing logic that ties bottlenecks to source code, get the insights you need in less than 4 minutes, without dealing with the overhead of enterprise platform feature bloat. You can rest easy knowing Scout's on watch to help you resolve performance issues with Scout's real-time alerting and weekly digest emails. As an added bonus for DevDiscuss listeners, Scout APM will donate $5 to the open source project of your choice when you deploy. Visit scoutapm.com/devdiscuss for more information.
It's one thing to have develop your own awareness for some of these concepts, to be able to make the trade-offs yourself between code duplication and flexibility. But how do you go about having this conversation effectively with team members who might see a PR you put up and complain that maybe this is code duplication, whereas your feeling is that it's an appropriate amount of duplication given the trade-off? How do you go about having these conversations with colleagues and perhaps managers or other stakeholders in the business?
Yeah, so the good solution is to just propose 2 solutions. If you have enough time, maybe create just 2 pull requests and with both approaches and discuss that, right? You can decide which one is better and see in the code if that's quite isolated and a small change. At the higher level, you need to understand that also duplication requires some synchronization efforts, maybe between teams, maybe between code paths. Yeah, but those two chapters that I've discussed are more low level, right? At the code level. And this is the first part of the book. And second one is transitioning to more architectural and like end-to-end understanding of your systems. And this fifth chapter, as you mentioned, about premature optimization and optimizing hot path. So it's also premature optimization, this is the well-known rule that it's a root cause of all evils, someone told that. And everyone is afraid of optimizing code upfront. However, I'm stating and I'm trying to convince that if we have enough data upfront, we can turn this premature optimization and just-in-time optimization on or something like this. So we need two things there. First is like some kind of an SLA or some kind of a guidance how big the traffic will be, so the throughput of your application, of your endpoints, of your APIs. But this is not enough, and this framework that I'm proposing, you also need to have the latencies collected per endpoints. So it can be collected using some performance tests that I'm presenting approach to do this, or also from SLA. And once you have both of those data points, you can calculate relevance of code paths in your code. And often turns out that most of the endpoints, most of the features impact the lesser part of the system, the lesser part of the users. And on the other hand, smaller part of the system, smaller code, provides most of the business functionality. And it means also that you can isolate your efforts on optimizing the small part of code. And also this is observed in a lot of systems, not only software systems. There is a Pareto principle that states that 80% of the value is delivered by 20% of work, right? And it relates very well to also most of the software systems, because often the smaller part of the code is responsible for most of the users. And once we detect such a code, I'm calling it hot path, it's a lot easier to focus optimization efforts on this part of the code.
So once you've identified this hot path and you've created the opportunity for some isolation and generally like you've gone through the framework you're proposing, when it comes to optimization at that point, in the optimization process, what are the trade-offs you have to balance in terms of maintainability versus optimization, once you've identified isolation? So that's probably the first step, ensuring that the optimizations you make can be done in an isolated enough way and structured, well enough. But when it comes to doing the work, how do you then ensure the trade-off between quality, maintainability, and optimization and performance?
That's a good question. So yeah, once you detect this hot path, depending on your guidelines in the code, for example, if you detect the code that is touched by every user, it means that you need to focus your efforts there, right? And maybe in such a case, you can sacrifice, some code readability over the performance of the code, because often when you are highly optimizing the code, it suddenly stops to be so readable. Maybe you need to reduce usage of some patterns and so on. So you have hard data justifying your decisions that this is part of the code that we should trade off this performance over readability, over maybe maintainability even, because we are improving it for all of the users.
And this might be a time when you actually create duplication even when don't repeat yourself practices were already in place, because you might come along a shared implementation of a solution that's used across the application. But in this case, it's worthwhile to rewrite that shared code in such a way that it's going to have a meaningful performance impact.
Maybe yes. Mm-hmm. But I would search for a bit different trade-offs here. Like for example, trade-off also the cost that you can spend there, right? This is development cost versus improvement of the performance. Also, what's interesting is that when you will focus your improvements on the hot path and you improve it for let's say, 10%, 20%, and so on, there may be a point in time when optimizing code path is not giving the overall benefits enough to justify changing it. Maybe then you can focus on those paths that are executed less often, like some, I don't know, initialization logic that takes a lot of time, but it's executed very low amount of time, like one request per, I don't know, minutes, hours, but maybe it takes a lot of time. But as I said, you need to have this data regarding number of requests, throughput, and also latency. So you can base it on average latency, but also you need to be aware of outliers. How many outliers do you have based on percent? You can find it based on higher percentiles, like 99th percentile.
Are there any other chapters in the book that you find yourself wanting to talk to people more about, like that come up a lot?
Yeah, so I think chapter 10 and 11, and the reason is that they are focusing on distributed systems and trade-offs in them. Nowadays, I think like almost every engineer needs to tackle some kind of a distributed system, needs to interact with such a system, code such a system, or design it, right?
So chapter 10 is consistency and atomicity in distributed systems, and chapter 11 is dealing with delivery semantics in distributed systems. So before we get into this, can we even just briefly define distributed systems?
Yeah, so we can define as a system where you need to call something that can fail, and you are calling it maybe via network.
That's very concise and well put. So consistency and atomicity. So what do you mean when you even use those words and in this context?
Those words may be complex, and someone can be scared by them. That's why in this chapter I'm trying to build up on the very simple example. So assume that you have one service and you need to call a second API, and that's it. It can be via a HTTP protocol. You are executing a HTTP call, and what happens when the call is failing? Well, the call failed, and you need to make a decision. In that moment, you have a distributed system problem. Why? Because when you are calling one service to the other, the call may succeeded, but when the response was coming back to your system, there could be a network partition, network failure, and the response didn't arrive to your system. And what does it mean? So it means that from the perspective of the second service to which you are sending the request, everything went well. But from the perspective of the caller, there was a failure. In that scenario, we have not consistent view of the system, although the data may be good, right? And you need to make a decision what to do at the caller side. One solution would be to just retry the request, but you need to have the idempotent operation, meaning that you can retry it safely without any problems. So all data retrieval operations should be idempotent. Also, delete operation should by primary key that is unique should be idempotent, because it doesn't matter if you delete one or two times, it always will be deleted. But there are also other operations that may be not idempotent, and in that situation, it may be not so easy and wise to retry. For example, if the second system is sending email based on this notification, and then it's connected with the next chapter, so about delivery semantics. And also this behavior that you are retrying means that your system is basically providing at least once guarantee at this code path, because the receiver application can receive this message once or more times, depending on the retry behavior, but it will be delivered eventually, assuming that the network will work again. On the other hand, you could, at the caller side, do not retry such a request, but in that case, you are risking that the situation was different. So the second, when you are calling this initially, the request failed, not response, when it come back to the first application, but the request. And in that case, you have, again, inconsistent system, but if you are not retrying, the receiver application may not receive it at all. So you have at most once, it could be received 0 times or once at most. And there is like golden solution maybe for some people that is effective exactly once. So trying to implement a system in a way that this duplication will not occur at some level. So it can be achieved using some kind of global logs on the system. It's not performant. It can be achieved by some deduplication mechanisms. So duplicating those retries based on a specific ID, but also it has some problems. The duplication mechanism often needs to be persistent because you don't know because the retry could arrive after 1 hour even, right? Depending on the system. There are some streaming systems that could retry events after quite long time if you have backup strategy and so on. Yeah, and in that case, you need to persist this information about processed events for the case of the duplication mechanism. And when the persistence comes in, you have another distributed call, right? So the same problems, also you need to solve them. Ideally, you would like to have some kind of an atomic way to modify structure in the database. And some NoSQL databases provide such a possibility, like it's called lightweight transactions. But also you need to be aware of those mechanisms and this API and those problems.
My friends and I were talking this weekend about the best movie sequels. Pun intended. Blade Runner came up, Empire Strikes Back, Aliens, and then we started talking about the best database sequels. The most fun answer here is CockroachDB. The founders came from Google, and they've basically spent the last 8 years building open source Spanner. But better. It's distributed SQL. It scales fast. It's super resilient. Hence the name. And they're doing some really cool stuff with data locally so that you can serve local experiences to users all over the world. The best part might be that you can use CockroachDB's serverless database for free until you hit a product to market fit. Try CockroachDB for free at cockroachlabs.com/devdiscuss.
The final chapter in the book is called Keeping Up to Date with Trends versus the Cost of Maintenance of Your Code. This one seems like a good final chapter, has a lot to do with, where you're spending your time, even, like the trade-offs in your own learning, but then obviously like rewriting code or re-implementation. Can you get into, the lessons you're trying to promote in this chapter?
Yeah, so often, I think once a couple of months or once couple of years, there are new technologies, new approaches that are gaining traction a lot. Like microservices architecture was gaining traction years ago, reactive programming, some specific patterns like functional or approach to programming, functional programming, dependency injection as a pattern, and so on and so on. And there is a moment when everyone wants to use it, regardless of the context in which people operate, right? And I'm advocating for that. This is a mistake in most of the cases because every new technology comes with the cost, and sometimes this cost is hidden because it's not tested by everyone yet, or some inherent complexities, like for example in reactive processing, this processing is totally different than imperative processing, when you can reason about your code easier if you learn this model firstly. And picking reactive, for example, reactive processing patterns may add this complexity, maintenance, and even bugs. And if you do not benefit from the pros of such an approach, maybe it's not worth adding it to your code base. Maybe first you need to also understand the trading model of the solution that you pick, the ecosystem, right? And so on.
What about the trade-offs in your own process and career between, staying focused at the problem at hand and writing a book, taking a step back to take the time to introspect and to create some of these rules? Like, what about your own trade-offs and even deciding to do this? Like, if I want to write a book, I feel like a lot of even the decision is a trade-off between where I want to spend my time and even where I want to deepen my expertise. And maybe where I'm getting with this in some capacity is that you're most likely going to be writing a book about things you deeply understand in the moment. So there's maybe a trade-off versus like expanding to a new technology. So while you were writing this book, you were probably not learning, a new paradigm, which could be interesting or valuable. What was that process like, as a sort of framework-oriented thinker in that regard?
Yeah, so from my experience, when you are trying to write about some topic, you need to express your thinking in a bit different way. And also it lets you understand things in a different way. And also sometimes even notice something that was unnoticeable before. That's why also engineers, when they are solving some problems, sometimes they want to talk with other person, even if that the person will not respond. Just asking a questions is sometimes will allow you to solve some problem. Also, I have the same experience when I'm doing some workshops from specific technologies. Always, I think on every workshop there is 1 or 2 questions that allow me to expand my knowledge. The process also for defining what should be written allow you to learn new things as well.
Do you consider any of the chapters to be controversial at all? Like any major pushback on the premise you're putting out there with any of this?
I think maybe a bit the second one. I'm proposing approach to actually calculate the cost of the duplication that comes from the fact that you need additional synchronization once the code is shared between people. And I'm adapting the Amdahl's law for that and showing some simple calculations. Besides that, I don't think so.
So like the book's place in the ecosystem is not necessarily to tell the world something they're not ready to accept, but to sort of explain it in such a way that is helpful to the individual.
I think there's a stage in a career when everyone wants to jump to the next level, try something new, like go to the company that has a bigger scale, different problems, maybe company that solves complex technical problems, technology problems. Then such a person will need to learn about it, right? And I think books are good resources for that, for sure.
Thanks so much for joining us today.
Thank you also for inviting me.
This show is produced and mixed by Levi Sharp, editorial oversight by Jess Lee, Peter Frank, and Saranya Barak. Our theme song is by Slowbiz. If you have any questions or comments, email pod@dev.to and make sure to join us for our Dev Discuss Twitter chats every Tuesday at 9 p.m. US Eastern Time. Or if you want to start your own discussion, write a post on Dev using the hashtag Discuss. Please rate and subscribe to this show on Apple Podcasts.